things intersect or where they cross. How did you guys find where two lines intersected or crossed? What methods did you use? What's that? Okay, so one option is graphing. So that's where we're going to let the calculator and the technology help us, because especially when we add something more complicated in, like a parabola, sometimes the lines don't cross at a nice clean point on the graph that we can see real easily, okay? So we are going to graph them and solve that way, specifically with our calculator, okay? So we'll do that at the end to confirm some of our answers. What are the other ways that we can find these intersection points besides graphing? Graham can't answer all the questions for you guys. I totally appreciate it, but Jenna. Good. So elimination's another method, and what else? And substitution, okay? So we can do all the things we did before to get it started, and then the method of solving, because a squared shows up, just might end up being a little bit different. So these ones are set up like y equals, so substitution might actually work pretty well. That I can substitute the fact that y is equal to negative 3x plus 4 means in that first equation I could replace y with negative 3x plus 4. So I'm going to go ahead and set up negative 3x plus 4 equal to x squared plus 3x plus 9. Now I have an equation, at least that all has x in it, and then I have to know how to solve this equation. So this is a quadratic, right? It has x squared in it and some terms with x and a constant. So our options for solving quadratics, factoring, quadratic formula, or completing the square. I'm going to lean away from completing the square, just like you guys normally do. And like I said, as we get to the end here, the homework might have asked you to complete the square, and I might have asked you in the little superhighway review, but I'm not going to ask you on the test specifically to have to use completing the square. I might ask you to rewrite something in vertex form or to solve something. You can choose how you're going to do that. So I'm going to set it equal to 0 and see if it's factorable. Factoring is pretty quick. And then if it's not factorable, I'll move on to using the quadratic formula. So to set it equal to 0 so that I can look at those options, I'm going to cancel out the terms on the left side. So I get x squared plus 6x plus 5 when I bring all the terms to one side. So that's definitely factorable. The numbers that multiply to make 5 and add to make 6 are 5 and 1. So this factors as x plus 5 times x plus 1, okay, which means what? Good. So x can equal negative 5 or negative 1. So remember what Graham said at the beginning. When we're solving the system, we're trying to look for the points where these two objects cross. When you have a parabola and a line, they could cross twice. They could cross once, okay? They could not cross at all, okay? There are a few different options. The fact that I found x equals negative 5 and negative 1, how many solutions do you think we have? How many places do you think this line crosses this parabola? 2, okay? At 2 points, because we have found 2 different x values. Have we found the complete points, the coordinates of the point where they cross? No. What we found is negative 5 is the x coordinate of one of the points, negative 1 is the x coordinate of the other point, but we haven't found the y coordinates yet to complete our solution. Okay? When you have x coordinates and you need to find y coordinates, how do we do that? Good. We plug it back in. And it shouldn't really matter which one we plug it into. I mean, personally, I'm going to choose the line because I don't want to have to do all the squaring and stuff. But if these two things really are crossing at that point, it wouldn't matter. You'd get the same answer either way. So if you're ever a little suspicious of if you did something wrong and you aren't sure if these x values are really the solutions, you're not convinced, okay? If you took one of them, like say negative 1, and I plug it into the line, I get 7. Okay? When I take negative 1 and I plug it into the quadratic, I get 1 minus 3 plus 9, which turns out to be 7. They should turn out to be the same because these are supposed to be the places where they're touching, where they share a point. So negative 1 should come out with the same y value no matter which equation I plug it into if it really is the x coordinate where there is a solution. So kind of a way that you could check if you felt like you made an error. And then if I plug in negative 5, I get 19. So those are the two places for this parabola and line cross. Is this okay with everybody? Questions? All right, go ahead and try part B. Solutions? All right, so let's see. If we set by substitution, we can kind of set it up the same way. Equals x squared minus 3x plus 4. Is that right? Okay. Is that factorable? No, right? Okay. If the 4 was negative, it would be factorable. Okay. We could use 4 and 1, but because it's not, we can't. All right. So then we would go about quadratic formula. Okay. And if we want to take a sneak peek before doing the quadratic formula, because Graham is telling me no solutions, okay, we are trying to find the place where they cross on the graph. The graph only has real numbers on it, so we can say no solutions if we can't figure out an x-coordinate that is a real number, since we're looking for a point. So if you want to check real quick before you dive into the quadratic formula completely, what could you do? Good. We could find the discriminant. So we can just check off to the side. It doesn't mean you can't dive in and go do the quadratic formula. It just means if you're thinking about it and you're not going to do that yet, you have some options. So if I check just the part that would be underneath the radical, the discriminant of the quadratic formula, I would get 9 minus 16, which would be negative 7. So that tells me that I have negative 7 underneath my radical, and that I would have to use imaginary solutions, which I can't plug back in and get a y coordinate. They don't show up on our coordinate plane. Okay? They operate in a different coordinate plane. So we're trying to find a place where this line crosses this parabola. There is not one. Okay? So no solution. And then, what's the difference with part C compared to parts A and B? Yeah, both are quadratic, so we can still set it up generally the same way, but we're going to try and go ahead and do this one on our calculator so you guys can learn how the technology could find the intersection points if you weren't doing it yourself. Okay? All right, so again, you're going to go to your y equals. You're going to type in the two equations for the system that you were looking at. Okay. So I'm going to go to y equals. Okay, notice my plot 1 up here is dark and bold. That means it's turned on. I don't really want to be doing other things with the data plot turned on because sometimes the calculator has an error because it's like having a hard time trying to graph what you want and the data at the same time. So I'm going to scroll up to that plot 1 and press enter on top of it and scroll back down. Now it's not bold anymore, which means it's not turned on. Okay, so the calculator will just graph now what I type into the equation parts. And so then I'm going to type my x squared plus 9x plus 7. If I type in the wrong equation, somebody tell me. I wrote them down quickly from your note guide. And then I'm going to be really careful with the second equation. It was negative x squared. You guys need to be careful to use the negative and not the minus if you're typing it first. So negative x squared plus 3x plus 7. Now I'm going to go graph them. My window was set before to view some random data that I had in there. So when I go graph them, I don't really know where these parabolas are. The numbers don't seem too huge. So what I want to do right now is just set my window back to the standard, like negative 10, positive 10, negative 10, positive 10. So remember, I can either go type that in myself, or if I go to zoom, I can choose choice 6. That's the standard window. So I'm going to go zoom 6, and here's what I get. Okay, so I can kind of see what's happening. I can see the concave up parabola and the concave down parabola, and it looks like they cross each other at 2 different points, right? If I want to see those points a little more clearly, it seems like I would want to see a little bit more down below here. So I'm going to go in and change my window to go a little bit further down than -10. So I'm going to click on window. And because it's up and down, I'm talking about the y's. And because I'm talking about down at the bottom, I'm talking about the y minimum. I want it to go further than -10. So I'm going to scroll down there and just say maybe -15. See if that's enough. And then I'm going to press graph. So that's a little better. I can clearly see both intersection points. Okay? So the calculator, I don't know if you guys remember, but the first time we went to calculate stuff like the vertex point or the intercepts, we went to that calculate menu. We're going to the same place this time. So we're going to go second and then hit the trace button to calculate. And remember, we have these first 5 choices, and when we were looking for the zeros, some of us were like wanted to say intersect because we were thinking about where it hits the axis. But we actually want to use intersect in this case. So this is when you want to use an intersection, where you've graphed more than one thing and you're trying to figure out where they hit each other, not where they hit like the axis. So we're going to choose choice 5, intersect. What it does then is it puts the cursor on a curve. So if you use the left and right arrows, you can see which parabola you're on, because it's a little hard to tell right now. But watch as I move the cursor. So I can see I am on, I think the one that's concave up, yeah. Okay, there's the parabola that I'm on. And as I move left and right, I can move back and forth along that parabola. Notice the calculator is asking me first curve and a question mark. So it's saying, can you please go to the place where you feel like they intersect on the first one and press enter. So I'm going to scroll along this. I'm going to find this top intersection point first. The closest point I think that it is to the intersection, and I'm going to press enter. And then it looks like nothing happened, but notice that now the calculator is saying second curve question mark. Now if I move left and right, which as you get better at this, you don't have to, but I just want to show you, your cursor is now on a different curve. Do you see? So when I pressed enter, it marked that, and then it switched me to the other thing that was graphed and says, now on the second curve, can you go to the place where you think that it intersects at that point, and can you press enter again? So a lot of times you could press enter right away because our cursor was kind of already in the right place. So I think it's like right around there somewhere. I press enter. Then it says guess, and I press enter. And it gives me this point, okay? So the x-coordinate says -7e, -14. Do you guys remember what that is? So the e in the calculator is the scientific notation talk. So 10 to the -14th means 13 zeros after the decimal and then 7. So really I'm going to call that coordinate 0, okay? So I would call this 0, 7 is where these seem to intersect. And remember, the reason that your calculator isn't giving you maybe the exact value, why we had to round it and know that it was 0, is because it's doing a calculus thing with the 2 curves to approximate where they must cross based on when it passes certain values and stuff like that. So that's why you might have gotten something different. Did you guys get something different on yours? Anybody? Yeah. He just got 0. Yeah. So like he picked better points than I picked, and so I was able to find it exactly at 0. But I should be able to tell that mine means 0 because I understand what the calculator is doing. Is that okay with everybody? Okay. So now I need to find the second intersection point. So go ahead and go through the same process and find the second intersection point. I'm going to do it as well. So one thing that we've learned about the zeros and intersection points, you can't find them all at once. You need to go through the process multiple times to find multiple different parts, okay? So I got from my second intersection point -3, -11. Okay. So again, once we start graphing on the calculator and finding these things, what we've basically done is learned how to enter things in the calculator. Data is one thing, and kind of regular graphing is another. For the regular graphing, We've learned how to enter things in the calculator and then adjust our window so we can actually see things. And then once we see what we want, all of the calculations, whether we want to find the roots or the zeros, the maximum or minimum, which is the vertex point, or the place where two things intersect, are all in that calculate menu. And then you just have to follow the calculator's instructions and understand what you're pushing in order for it to find the pointer. Does that make sense to everybody? Okay. All right. So are we good with systems? We can solve them by hand, and we could use technology to find the places where things intersect. Okay? So then the last thing we're going to do is, what if it's a system of inequalities? Okay? So this is kind of like we worked on yesterday. So the very last example in your notebook. So the difference between solving an equation and an inequality is when you're solving an equation, you're finding the exact points where they cross, and you go and look for those exact coordinates. However, when you're finding solutions to an inequality, remember how an inequality is different than an equation like we talked about yesterday? Your solutions aren't just along this border. There's this whole mass of solutions on one side of the border. That's what your shading is representing, right? So for these, our answer is not a point or some numerical value. Our answer is a picture because we can only represent all those infinite points in all this area by drawing the picture and then showing them it's all these things over here in this region that overlap, okay? So when it's an inequality that we're trying to solve in a system, we have to graph it, okay? So this is two quadratics, so we're going to have to graph each quadratic, and then we're going to shade. So go ahead and take a minute. I'll do the same. Get some important information about each quadratic. So take each one separately for a minute, okay? You can use your calculator because the vertex is going to be, I can already tell because it has odd numbers for the b value, and we're going to do negative b over 2a, right, to figure out the vertex point. So it's going to be like halves and stuff. So if you use your calculator just for calculation, you can. But go ahead and find the vertex point that we want to plot, and then we can use like this intercept. So I'm going to take each equation and do that. You guys can do the same.